before starting any work on this Benchman MX, I jumped through some hoops getting this old Windows XP machine up and running so I could test out the machine with the original software. The software works great, however, I'm a little apprehensive about moving forward with it, as if anything goes wrong with this old PC or the proprietary controller, I'm going to be out of luck getting any replacement parts probably. So I'm going to move forward with doing a full retrofit. So I took off the X-axis motor cover plate just to see what I'm working with here. You can see it's got a DC motor and then it's got a separate encoder. So the motors I was going to use are these AC servos, 400 watt, and it fits in here quite nicely, so I think that's going to be awesome. I also took apart the spindle motor here. I noticed it wasn't working whenever I tried to test it. I don't know if it's the motor or the driver or who knows what. Anyways, I think I'm going to replace it with a 1 kilowatt servo motor. See how that works? I've removed the pulley from this DC motor. I'm going to try to bore it out to fit this new servo motor. I removed the bulk of the material on the mill so I can fit my boring bar on the lathe. Alright, it looks like that's going to fit. Alright, let's get the Masso controller installed. I bounce around quite a bit in this project, as sometimes I only have a small chunk of time to make some progress. I design a new top plate to hold the new spindle motor and the pneumatic cylinder, and I get some time to get that machined out of aluminum. Here's the original top plate and the new one ready to install. Should fit right about here. Okay, I've got that installed along with the new 1 kilowatt servo. Next I can get the pneumatic power drawbar installed. Check out my other video if you want to see how I built that. Then I have to do some disassembly so I can get access to remove all the old motors and encoders. I designed some new servo motor mounts in Fusion 360. Okay, here's my servo mount. I printed it out of a glass-filled ABS and it's extremely rigid. I was gonna mill these out of aluminum, but I don't know. I think this might just be totally sufficient. I also model up some temporary pulleys and add some threaded inserts for the grub screw. You can see I've put on a 3D printed 14 tooth pulley on here. This is just a placeholder. I have some on order from China, but they're going to take like a month. So I'm going to go ahead and move forward with these while I get everything set up and testing. I get the Y-axis motor installed and the cables routed. That was kind of a pain, but I managed to get all the wires run for the servo motor back to the back of the cabinet, so I can go ahead and close this part up. Then I install the X-axis servo and get the cables routed. I'm moving right along here. I got the Z servo motor all wired up. Alright, with all the motors installed, now we can move on to getting this stuff wired up. I've got the back of the unit opened up and I need to start removing old electronics. My servo drives, they fit, but by the time I plug anything, it's going to be too wide. So I think I might mount them over here. I got the 4 drives installed. I think that's going to work fine. I can easily access all the menus to change parameters and stuff. I get files set up for some DB25 breakout board mounts and some washers for my aviation plugs to be laser cut. There are the parts. They turned out fine. These are going to be mounts for these DB25 connectors. I get these two aviation plugs installed. They're going to be connection points for my 4th and 5th axis. Then I can get the two stepper motor drives installed. I install one more power supply that can output 5 volts and 12 volts. I get the hook installed for the hand pendant. Alright, I drilled 2 holes here in the base here to run the cord for the Touch 3D Touch probe and one for the hand pendant. And I'll silicone those holes once I get them all set up. I've 3D printed this mount for my tool setter. I think I'm going to put it over on this corner for now. Alright, that should work. Next, I designed this piece to mount my bank of solenoids to the back of the machine. Right, there you can see my laser cut part mounted to the back of my bank of 4 solenoids. That was also I could mount it up here, right on these 2 threaded holes. Cool, I think it's gonna work well. Alright, I need to install some den rail up here. I'm gonna try to use these existing studs here so I can install this terminal block. Now I'm going to replace all these breakers with properly sized ones for my components. Alright, I've started running power to all the devices, and yeah, all the power supplies are wired up, all the servo drives and the stepper drives. So yeah, it's starting to come together. I get the DB25 cables routed from the Masso back to the terminal blocks in the back. Alright, I got both of those wired up, and so now we can start actually hooking some stuff up. I like this original front control panel, but it doesn't have all the functionality that I need, so I designed a new one in Fusion 360. You might have noticed this was my second attempt at cutting out this control panel. The first one I left these micro joints to hold it in place, but it really marred up the surface of the stainless steel. Anyways, now I can get all the buttons installed. Alright, well it's going to look something like that until I can get the graphics printed on it. Or laser etched. We'll see what I end up doing. That will be the tool release button, program start and stop or feed hold, mist coolant on off, flood coolant on off, and two just auxiliary buttons for whatever I want to assign them to, and then e-stop, of course. Once I get my UV printer fixed, I'm going to try to print the graphics of like this emergency stop and some labels and stuff. And I finally get some power hooked up to the Masso through a 1 amp fuse. I load the software on a USB drive and get that installed. And it's up and running. Alright, I got my cables ready for the 3 servo motors for the gantry. Go ahead and get those installed. Alright, if I did everything right, the motors are all wired now, so let's turn it on and see if I can put in a few default values and get them to move. You can see I can jog everything now. Cool. Now I need to adjust some parameters in the servo drives and change in the encoder resolution since it's geared down by 2 with the pulleys. Alright, after that adjustment, you can see it's jogging twice as fast now. Alright, I'm ready to wire up this servo driver for the spindle. Got it plugged in on the other side. Alright, cool. Now I can hook it up on the front side. Alright, last 2 wires here, then the spindle should be good to go. I'm going to control it using step and direction signals. So I can do clockwise or counterclockwise if I need. Alright, let's see if we can make this spindle work. Because my servo motor has a max RPM of 6,000 and there's 1 to about 0.7 gear reduction with the belt and pulleys, I have the max RPM at 440 right now. I'll probably see if I can do something about that later and change the pulley ratio to get more RPM out of it. So let's try that. Alright, let's try clockwise. And counterclockwise. Awesome, cool. Alright, my actual 14 tooth pulleys came in, so I'm gonna swap out these 3D printed ones. I go ahead and finish swapping out the pulleys and getting all the motors reinstalled. Next, I solder up this connector to get the hand pendant installed. Alright, the pendant's all hooked up and it looks like it's working. I can put on X. Y. These stuff works. I got my 4th and 5th axes set up. I need to make a hole for the cooling fan for the control cabinet. These cordless drills just love 4-inch hole saws. They've been through much abuse and it'll be fine after it cools down, but I have another one for now. I know some people like to knock Ryobi tools, but I've had these for years and they just won't die. And that should move some air. I also need to make a hole for air input on the door. So I model up a quick cover plate, 3D print it, and get it installed. That should work. Next, I model up this adapter so I can get my mist coolant sprayer mounted. There's the finished piece. I just have to tap a couple holes and get that mounted. Alright, looks like that's gonna work nicely. I need to make some holes to mount my trunnion table, so I set up a file here to do the job. Here's my modified plate, so now I gotta get this back together. I got the 4th and 5th axis installed on the side with the modified mount, so we'll try that. Next, I model up this tool holder rack. I'm gonna laser cut the back panel and 3D print all of the individual tool holders. Here's the finished panel. I deburred that one area and knocked out of the holes. I'm going to mount it somewhere right about here and attach all the tool holders. Alright, last tool holder. Cool, I think that turned out pretty nice. It turned out the original type of relays aren't going to work with a Masso, so I bought this little breakout board with 4 relays and 3D printed this little mount for them. Alright, I got my front control panel done except for printing the graphics on it. E-stop works, mist on and off, and the spindle release button. Right now I have this one for homing, and I'm unsure what I want to assign this one to yet. Okay, I'm ready to mount the vise, but there's this little lip on the chip tray that interferes with it, so I need to make this little riser plate for it to set on. Here you can see the little lip that's in the way. Alright, I've got this plate mounted here, and I'm just going to take and use a face mill and mill off that top surface so that it's all level with the machine. Okay, now we need some vise clamps. I set up this design in Fusion 360 just for dimensions. They're simple enough parts, I'm just going to manually mill them. Alright, I've milled out some proper vise clamps out of steel this time, so let me get those installed here. Alright, those turned out really nice. Now I just need to tram in the vise, and then I can start making some test cuts. While I have the dial indicator out, I go ahead and precisely calibrate all of the steps for the servo motors. On my Super Pro Light mill, I started out with 3D printed clamps, and then I upgraded to these aluminum clamps for the vise. And now, as a first test job on the Benchman, I'm going to mill out some new vise clamps out of steel like I did for this machine. Alright, I got my 4 pieces of stock cut off. Now I'm going to start manually bringing them down to dimension.
4 pieces squared up.
I probed the corner so I can calculate the position of the hole I need to drill. Alright, so far so good.
Alright, just one more step and then they're done.
Alright, they turned out pretty nice and the new machine was a real pleasure to use. So let me get this cleaned up and installed. I'll go ahead and get this trammed in for the new lucky owner of this machine. At the time of editing this, I've already sold this Super Pro lathe. It served me very well over the past year, and I'm really going to miss the ATC. But I'm looking forward to using this Benchman MX. I got to the end of the video here and I realized I really never explained why the upgrade. The Super Pro lathe was a great machine and I'm really going to miss the ATC part of it. But this machine has several things that I consider upgrades. So one is obviously the enclosure. It's all set up for flood coolant. I just need to get a pump and get that installed. Also, this machine has 6 inches of extra travel in the x-axis, which allows me to set up the rotary and leave it there permanently, which is awesome. Also, this machine has slightly beefier square rails instead of the round rails on the Super Pro lathe. That in combination with the servo motor as the spindle, I get much better low-end torque and I've noticed better surface finish, which is awesome. And also, I just enjoy retrofitting these machines. Anyway guys, thanks for watching and thanks to all my Patreons for all your support. Thanks guys.